Namaste students, and this video is the second part of exponents. At the end of the session, students, you will be able to represent a decimal number in the expanded form using exponents. Express very large and very small numbers in standard form. Yes, as I told you in the last video, in this video we are going to see some examples. Before that, I just again recall the laws of exponents. What is the first law? A power m into a power n. When the same bases are multiplied, the powers are added. That is a power m plus n. And second law, a power m divided by a power n. If same bases are in a division, the powers we have to subtract. That is a power m minus n. And a power m, the whole power n. Then you can write it as a power m into n. And fourth law is a power m into b power m. Here you have to see carefully. In law 1, the bases are same. In law 4, the power, that is index, is same. So you can take it as a common index. So I written ab the whole power m. And law 5, a power m divided by b power m. Same you compare with law 2. Here a power m divided by a power n, same base. But here same index. That is a power m by b power m. So I can take it as a common, right? So a by b the whole power m. Or shall we write it as a power m by b power m. And sixth law is a to the power 0 is equal to 1. That is anything to the power 0 is equal to 1. And the last one is minus 1 to the value, index value is an odd number. Then you will get minus. If minus 1 to the power even number, that is the index value is a positive value, then you will get positive value. Okay, we are going to use all these laws of exponents to simplify the sum. So I have taken few examples. First example 1. Simplify the following: minus 7 to the power minus 10 divided by minus 28 to the power minus 10. So first I am going to write this one in a division form. That is minus 7 to the power minus 10 divided by minus 28 to the power minus 10. And what I can do the next? Here I am having a negative power. So if you are having a negative power, you just bring it to the denominator. Then the power, the sign of the power will get changed. So I am going to bring the minus 7 to the power minus 10 to the denominator. So it will become minus 7 to the power 10. Same way, I am taking this minus 28 to the power minus 10 to the numerator. So I will get minus 28 to the power 10. Okay. And now what I am going to do means, here the base is 28, here the base is 7. They are not having a same base, right? But we are having a same power. Okay, fine. So shall I take it as a common power? That is, I'll write it here, the law a power m by b power m is equal to a by b to the power m. So in that way, I'm going to write it as minus 28 by minus 7 the whole power 10. Okay, And now we all know this minus and minus will get cancelled. Okay. And then what you will get? 28 by 7 to the power 10. And shall I simplify this too? Yes. 7 ones are, here 4s are. So the answer is 4 power 10. So what is the property I had used here? That is a power m by b power m is equal to a by b the whole power m. Have you understand? Yes. Now, a second subdivision. What is the second subdivision is given? 3 to the power minus 2. 3 to the power minus 2 the whole power 2 divided by 9 to the power 2. So first I am going to write it in a division, right? That is in a fraction. 3 power minus 2 the whole power 2 whole divided by 9 power 2. Yes. Now here I can apply one law. What is that law? Yes, think. Yes. A power m the whole power n is equal to a power m into n. The same way, minus 2 into 2 is what? Minus 4. So 3 power minus 4. Okay. And now in the denominator I am having 9 power 2. So shall I write 9 as 3 square? Because 3 3s are 9. So I am going to change 9 as 3 square and the whole power 2. The same law I am going to apply it again. That is 3 power minus 4 whole divided by 3 power 4. And here I am having a negative power over there. So shall I bring this one down? Yes. So what will happen? 1 by 3 power 4 into 3 power 4. So the same bases are multiplied. So the powers we can add it based on the law a power m into a power n is equal to a power m plus n. In that way, I am going to write it as 1 by 3 power 8. Or you can write it as 3 power minus 8. Both these answers are correct. Okay? Yes. Now, example 2. Evaluate this. So, the first subdivision is minus 3 by 7 to the power minus 3 into 2 by 7 to the power 2. So what is the first step I am going to do? I am going to distribute the powers. That is a by b to the power m can be written as a power m by b power m. So same way, minus 3 to the power minus 3 whole divided by 7 to the power minus 3 into 2 to the power 2 by 7 to the power 2. And here I am having a negative power. So I am going to take it to the denominator. This I am going to take it to the denominator, and this 7 power minus 3 I am going to take it to the numerator. It will become 7 power 3 by minus 3 to the power 3. And this one as it is 2 power 2 by 7 power 2. Now you can see 7 power 3 and 7 power 2. That means if you are having a same base in a division, what is the law? A power m by b power n is equal to a power, here it will get same base, right? A power m by a power n is nothing but a power m minus n. So I can write it as 3 minus 2. This will become 7 power 3 minus 2. And this one I can write it as 2 power 2 can be written as 4. And here minus 3 to the power 3. That is minus 3 is multiplied how many times? 3 times. So what will be your answer? Minus 27. 3 into 3 into 3. Okay. And then 3 power 1. 3 minus 2 is 1. So 7 into 4. 7 into 4, shall I write it as 28? So 28 by 27. I am going to write minus over here. So this is your answer. Okay. Here we use only two laws. One is a by b the whole power m is equal to a power m by b power m. Another one is a power m by a power n is equal to a power m minus n. And second substitution is 2 power minus 3 into 3 power minus 3 divided by 6 power minus 6. So first I am going to write it in a fraction form. So 2 power minus 3 into 3 power minus 3 whole divided by 6 power minus 6. And the next step is I am going to bring this 2 power minus 3 and 3 power minus 3 to the denominator and this one to the numerator. So it will become 6 power 6 by 2 power 3 into 3 power 3. You may notice they are having a same power. That means a power m into b power m can be written as ab to the power m, right? So I am going to write it as 6 power 6 by 2 into 3 the whole power 3. So 6 power 6 by 2 3s are 6. 6 power 3. And we are having a same base. The two are in a division. So I am going to apply the rule. What? A power m by a power n is equal to a power m minus n. So it will become 6 power 3. Sorry, 6 minus 3. Then you will get 6 power 3. Okay. Now example 3. You are going to find the value of m. The first subdivision is minus 4 to the power minus 3 into minus 4 to the power 7. So the same base is multiplied in the right hand side, right? In the left hand side. So minus 4 to the power minus 3 into minus 4 to the power 7 is equal to minus 4 to the power m. If the same bases are in a multiplication, the powers you can add it. So I am going to write it as minus 4 to the power minus 3 plus 7 is equal to minus 4 to the power m. And here what will happen to the index? Minus 3 plus 7. So it will become plus 4. So minus 4 to the power 4 is equal to minus 4 to the power m. Now the bases are same. Therefore the power is also same. By comparing this, I am writing m is equal to 4. Okay? Yes. Now second subdivision. In the second subdivision, you may notice all the bases are same. If same bases means we can add the powers, right? So shall I write it directly? Yeah. 8 by 9 to the power, what are the powers? Minus 4 plus 6, plus into minus is minus, right? So minus 8, that is minus 4 plus 6 minus 8 And in the right hand side, 8 by 9 to the power 2m. And now you can simplify this. We'll get 8 by 9 to the power, what will happen here? Minus 4 plus 6 is plus 2. Plus 2 minus 8 is minus 6. Minus 6 is equal to 8 by 9 to the power 2m. And we are having a same base, so the powers are also same. From that, I am writing 2m is equal to minus 6. Therefore, m is equal to minus 6 by 2, and that is equal to minus 3. Therefore, what is the value of m? M is equal to minus 3. Got it? Now, the last subdivision. This one is easy, right? Here they given 6 power m minus 3 is equal to 1. And if you see in the left hand side and right hand side, the bases are not same. But in this subdivision 1 and 2, we can see the same bases. So what to do? Just use the law over here. Here they given 6 power m minus 3. So I will give you the reverse one. That is a power m by a power n is equal to a power m minus n. So think in a reverse order. If the powers are in a subtraction, they were in a division. So I am going to write it as 6 power m by 6 power 3. That is equal to 1. And now what we can do? You just cross multiply. So 6 power m is equal to 6 power 3. Now you may see the bases are same in both the sides. So compare the index. M is equal to 3. Is it easy? Yeah. And now example 4. Here also you are going to find the value of x. After finding the value of x, you have to find the value of 3 power x and 2 power x minus 1. So the given is 5 power x is equal to 625. The bases are not same, right? So I am going to make the base as a same. Think of this 625. 625 can be written as, yes, 625 can be written as 5 power 4. Okay, therefore 5 power x is equal to 5 power 4. By comparing these two, I am going to write x is equal to 4. I found the value of x, and now I am going to find 3 power x. Therefore, 3 power x is equal to 3 power 4. What is 3 power 4? 3 into 3 into 3 into 3. 81. And next one is 2 power x minus 1. That is nothing but 2 power 4 minus 1. So 2 power 3. 2 into 2 into 2. That is 8. Okay? Easy? Yes. And now we are moving on to the next concept, standard form. Standard form. A number is said to be in standard form if it is written in the form a into 10 power n, where a is a number greater than or equal to 1 but less than 10, and n is an integer. That is, you have to write the number, given numbers in this form. The number can be any digit. It can be 7, 12, 15, whatever the digits, but you are going to write it in this form. Okay, children? Yes. The first example itself easy to understand the concept well. Yeah. Now, in the first subdivision, you may see this many numbers. Is it possible to write these numbers again and again in the sums? No. So that I am introducing a standard form. Okay? Yes. Now, in the first subdivision, you just notice that if the decimal is not mentioned, it is at the last. So I'm going to shift the decimal towards left side. Towards left side. So you just count number of zeros over here. Yes, start. Yes, completed. How many zeros are there? 27 zeros are there. So 9 into 10 to the power 27. So the value of this is same as 9 into 10 to the power 27. Okay. The same way here also in the second subdivision. First you just count the zeros. How many zeros are there? 15 zeros, right? And then here we are having 654, but you have to write a value A which is greater than or equal to 1, less than 10. So 654 is greater than 10. So I want to pull the decimal towards two places. So I am going to write the second subdivision as what? 6.54 into how many zeros? 15 zeros, and this two places. So 10 to the power 17. Okay, fine. In this first two subdivision, I had moved the decimal towards left side, right? And in the third subdivision, I am going to move the decimal towards right side. See the decimal over here? I am going to move this one to the towards right side. So count the zeros. Yeah. 8.0 into 10 to the power 15, right? No, minus 15, because we are pushing the decimal towards right side. That means division. Okay, fine. So you have to put the negative symbol in the index. That's what I written, 8.0 into 10 to the power minus 15. And fourth subdivision, same way. Yeah. Yes, that is, we have to move towards here. So I'm going to write it as 3.84 into 10 to the power 10, right? Minus 10. So you may see, if you are moving the decimal towards left side, the power is positive. Okay? If you are moving a decimal towards right side, the power is negative. Okay? Nothing. Here I multiplied, here I divided. That's it. Okay? Yes. And now, the next example. Write this number in usual form. Usual form means what? You have to write it in a, that is, we have to multiply this 10 power 8 towards here. That's it. So multiply it. Yeah. 2.37. So how many zeros I have to place? So 2, 3, 7. So 2 decimal places I move towards here, and then remaining 6 decimal place. So 0, 0, 0, 0, 0, 0. Okay? Easy? Yeah. And now, second subdivision. 3.6 into 10 to the power minus 6. Here, minus 6. So, the decimal is moved towards right or towards left? Towards left. Okay? We are doing the reverse. So, what you will get? How many places you have to move? 6 places, right? So 0 point, how many zeros I have to write? 5 zeros, because here I am having 3. So 0, 0, 0, 0, 0, 3, 6. Yeah? And now, example 7. Simple. We are going to add these two values. Here, the sum value is given as 3.34 into 10 to the power 20. And here 6.56 into 10 to the power 18. You may see here 10 to the power 20, here 10 to the power 18. First we have to make this to be the same. So is it possible to simplify this? No. So I am going to make this one as 10 to the power 18. For that I am going to shift the decimal towards right. I can write it as, here I put plus. So 334 into 10 to the power 18 plus 6.56 into 10 to the power 18. And now you can add it. While adding, what you will get? Will get 3 point. Is it right? 3 point? No. 340.56 into 10 to the power 18. While you are going to write it in exponential form, the number a should be less than or equal to 10. Right? Yes. Not less than or equal to less than 10. So move towards left. You can write it as 3.4056 into 10 to the power 20. Okay? Yes. And now the last sum, we are going to find the difference. The question is 5.6 into 10 to the power minus 6 minus 3.48 into 10 to the power minus 9. Yes. Which one you are going to change? This one. I am going to change it as 10 power minus 6. So this one as it is 5.6 into 10 to the power minus 6 minus, this can be written as 0.00348 into 10 power minus 6. Now find the difference. Yeah? Make it fast. The value is 5.59652 into 10 power minus 6. Yes, children, I think you have understand the concept well. Thank you.